Hey, Ma'am Jocelyn Ubas. I am Roldan L. Soriano Jr., and I am your student on BSBA Marketing Management. My topic is about Euler circuit and formula.
Euler circuit. So introduction, what is Euler circuit? So every topic, you need to ask what is the meaning of the topic. So because my topic is Euler circuit, so I need to ask what is Euler circuit. So in graph theory and Eulerian trail, graph that visits every edges exactly once. Similarly, a Euler circuit or Eulerian trail that starts and ends at the same vertex. For example, in this graph, you need to erase this first. So A to B to D to C, C to D. So as you can see, the starting is letter A and the ending is letter A. So this is Euler's circuit. This is Euler's circuit. So this is the one we need to consider. We need to start and end at the same vertex. Next, here. But here we need to cancel this line, the center. We need to cancel this line. So I started in A to B to D to E to C to A. So as you can see, A is the starting vertex and the ending vertex. One thing to consider with the Euler circuit is all of the vertices is even. So this letter A has a degree of 2, 1, 2, has a degree of 2, B has a degree of 2, D has a degree of 2, C has a degree of 2, E has a degree of 2. So all of those vertices has an even degree. So that is Euler circuit. That is the one we need to consider. As long as all of the vertices has the even degree. So for another example, in this shape, we need to draw a star. So we need to put A, B, C, D, and E. So in this shape, so in this star, we need to start to the vertex and end on the same vertex. I will start here in letter D. So D to A to C, C to E to B, B to D. Tama ba? Yan. So as you can see, D is the starting vertex and end into the D vertex. And it has a even degree. So to check this degree, it has BA. So all of those are degree of 2. So it's even. Need to consider also this degree. So for example, in this shape, so it's letter in this little shape. I don't know what shape is this. I think it's an arc, but it's 1, 2, 3, 4, 5. It has a 5 vertices and 5. So letter B, C, D, and E. So what happened if the letter the start of vertex is different with the end of vertex? So for example, let's start in letter A to B at A to B, B to C, C to D, and D to E. It's because difference A and E, so we need to call it as Euler's paths. It's Euler's paths. So it's not a Euler circuit because Euler circuit, it needs to start and end at the same vertex. You can add a graph such as like this, just to consider as Euler circuit. A to B, to C to D, D to E, to A. So A is the starting and A is the finish vertex. So this is how easy the Euler circuit to determine. So you need to remember always that the starting vertex and the end of the vertex is always the same. It has the even degree of Euler circuit. So that is Euler circuit. So next we have Euler's formula. Euler's formula. So Euler's formula, I write the formula in this. This is the formula, and I search it already in the Google, YouTube, but I cannot get the point of this. So I will just explain what is the meaning of Euler's formula, and I will be explaining back to Euler's circuit. I will be focusing on Euler's circuit. So what is Euler's formula? Euler's formula, named after Leonhard Euler, is a mathematical formula in complex analysis that establishes fundamental relationship between the trigonometric function and complex exponential function. So this is the formula. So I don't know how to solve it, but I'm trying my best to solve. But how many times that I already explained and try to discuss about this formula, but I cannot. So I am so sorry for that, and I will be going to discuss and back to the focus of Euler circuit. So on Euler circuit, I will give 5 examples. So as you can see that 1, 2, 3, 4, 5. I don't know if that shape or graphs called, I don't know. So I will show you how to define the Euler circuit. So for this shape, so it has A, B, C, C, D, E, and F. So start with letter A to B to C to D to E to F. So A to B, C, D, E, and F, and A. So this is Euler's circuit. Next here, let's have the numbers. So 1, 2, 5, 6, 4, 3, 2, 1. No, it's 3 and 7, 9, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and a letter 8. So let's start here. 5 to 6 to 4, 3, 7, 9, 8, A, 1, and this number 2 back to number 5. So as you can see, it's just the same. It has the starting line, starting vertex with 5 and end with a number 5. So next, let's check if all of this has a even degree. So 5, so we have 2 and 6, 4 and 5, 3 has 2 degree, 2 degree, and 2 degree, and 2 degree. So everything has 2 degrees, so this is Euler's circuit. So next, here, let's have Z, X, Y, A, B, and H. So let's have the Z to X to Y to A to B and to H to Z. To Z, X to Y to A to B to H to Z. So as you can see, again, it's Euler's circuit. Next, in this graph, so we have here this graph. So we need to put here letter, so it's a letter H, letter B, letter C, letter D, letter E, letter F. So we have 1, 2, 3, 4, 5, 6. We have a 6 vertices. So from this, let's start here with letter B. So B to C to D to E to F, F to B, and B to H. So as you can see, the finish vertex and the starting vertex is different. Like the starting is letter B and the ending is letter H. So this is Euler's paths. And it has a different degree. The H has only 1 degree, which is letter B. This is only a 1 degree. And all of those are even degree. So the lastly is this. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So just copy this number. 1, 2, 3, 4, 5, 6, 7, 8, and 9. To back to number 1. So 1 is the, and that is what we call Euler's circuit. So that's how easy how to determine the Euler circuit is. So hopefully you learn something about this topic, and see you next time. Bye.